I've been there several times, but it is far easier for Kieran to be involved with IBAAS, and I dare say he will be there.
No, Kiran will definitely will there. Kiran is representing many companies, and you are representing RIA. You have to be there, and it is. It's a lot of interest is there, and we are expecting about 300 delegates this time because we are getting fairly good response. Good number of exhibitors are coming. So we are making a lot of good arrangements, and I hope, Mark, you will make it.
Promises. Like I say, it's in my diary. We have some months to go. Let's see what else is happening around that time, and whether I also have a need to take care of some other visits in India at similar time. So no promises, but I am aware. Don't worry.
Okay. So please fix your meetings around October 8 to 10, and it's just after rainy season, and it's a little bit festive season in India between our before Diwali. It's a main festival in India. So you have come many times to India. For you, it won't be a problem. So anyway, we'll look forward. We will keep reminding you time to time. Okay?
I'm sure you will. Right.
Okay.
How many people do you anticipate will join the session
30 persons. There are a group of 4 or 5 persons from Sri Lanka also, from some extrusion company. And Priyanka of our office will send you a complete list if you are interested.
Okay, thank you.
So there are, I think, 25, 30 persons may join. And I'm not sure. We have sent, many have registered, but sometimes the last moment, some cancel, some more people join. So it's all your luck and our luck. How many people join?
Typical. I noticed this morning Kieran copied me on some emails that he sent out to some contacts suggesting that they join, but he's actually sent them the link direct. So it might be that some people join on the link without having registered, but let's see.
Yeah, let it be. But normally we insist, we request them to register first. And and just your first 2 slides where voice is little low, but afterwards it is picking up.
Okay.
So I will not introduce you much because you have given your introduction in your presentation. So I will just tell Mark Bumford, and he is from RIA Casting and one of the well-known person. And then I think it will start. So say another 3 minutes, another 8 minutes. 8 minutes. So we'll start. So already 5 people are there. Most of the people. Okay, so slowly people will join. Okay. And we keep it Friday as the last week of last Friday of every month we have. So we are running from 22nd, 23rd, 24th, and this is 25th. This fourth year we are running this kind of lecture series.
Okay.
Okay. Okay. So you are in Germany, no?
No, I'm in the UK. The company is in Germany.
Okay. But you are in UK. Okay.
I'm based in the UK, yes.
Okay. London or Oxford? We are in London?
Oh, on the south coast of England. So the town I live in is called Poole, Poole.
Poole. Okay.
And we're about 1.5 hours from London.
Okay, very good. Very good. Absolutely good. Hello, Mayur. How are you? One Patrick Paulson is there. I don't know Patrick. Okay, you'll get all introduction, and you have to be there all the time because just after your presentation, there will be question and answer session.
Yes. Looking forward to it.
Okay. Hello, ladies and gentlemen. And today our speaker is Mark Bumford. He's a mechanical engineer and is the sales director of RIA Casting House. And he will introduce himself in his presentation. and he's here in person. And this is about, say, 40 minutes presentation, and this will be followed by questions and answers. So please don't go away anywhere. And I will request Priyanka of IBAAS office to start the presentation. So you are all welcome. And in this interesting presentation of aluminum downstream, and please listen Mark Bumford about his casting machine. Okay, Priyanka, please start.
Good afternoon. Welcome to the technical lecture series. I'd like to thank IBAAS for making this possible. I'd also like to thank each and every one of you for attending today. My name is Mark Bumford. I am Sales Director of RIA Casthouse Engineering, GmbH. Company is based in Leipzig in Germany. I'm based in the UK. I'd like to talk to you today about how you can potentially increase efficiency in your cast house and certainly improve safety through the use of rail-mounted autonomous furnace tending equipment and smart camera technology from Fioscope for in-furnace applications. First, please allow me to introduce my company, RIA Casthouse Engineering, and our relationship with Fioscope. We originated from the late 1990s under the brand name of Rackwitz Industrieanlagen. Rackwitz is a small town just outside of Leipzig, and it's where we still today have our engineering workshop. Originally, we worked in both the cast house sector and downstream extrusion applications. In 2018, our original founder retired. The company transferred ownership to the son of the original founder, who took the decision to rebrand the company, picking the letters RIA from Rackwitz Industrieanlagen, rebranded the company as RIA Casthouse Engineering, the name that we go by today. It was not just a rebranding in name, but also a refocusing to work just solely in the cast house sector and two areas of particular expertise: rail-mounted furnace skimming machines and furnace charging machines. We are still today working out of the same workshop in Rackwitz, but we now have offices where we operate from in the city of Leipzig itself. As I already mentioned, I'm based in the UK. I have a colleague based in Pune in India, and we also have an entity in the United States which takes care of local service, spares and support, as well as sales for the Americas. We started our journey with Fioscope in 2014, where we became a customer for the first time of Fioscope. We had a client in the eastern part of Germany who was looking for camera technology in his melting furnaces, and we were doing a modernization in that cast house at that time. We searched on the market to see what was available, and we came across the Fioscope technology. We applied that to our customer's application. We used Fioscope as a supplier for a number of times until the year 2021, where we actually signed a formal agreement to make our relationship bidirectional and exclusive, that we would only use Fioscope technology for our applications in aluminium. They would only supply to RIA. That went one stage further in the year 2022, when the managing director of RIA became also managing director of Fioscope. We subsequently relocated the business from Freital in eastern Germany to Leipzig, where we now share offices and we share resources such as sales. My team within RIA head up the sales for Fioscope as well. Let's talk specifically about RIA, and we'll focus initially on furnace charging machines. But looking at the applications that we have for both charging and skimming, we have some 92 getting towards 100 applications of rail-mounted machines. Our business is split almost equal between European market and the Americas, although we have some applications in India, and we'll touch on exactly where shortly. We've supplied more charging machines than we have skimming machines. That makes logical sense in reality, because one charging machine will really only serve to multiple melting furnaces, but a skimming machine will serve to holding and melting furnaces, and can actually serve more of those than a charging machine can itself. Our customers, we've supplied to furnace builders such as GNA, Jasper, Incitec. They've integrated our technology and offered it as a package to their customers, the end users. But without a doubt, our largest single customer is Hydro. Hydro formerly operated as more than one entity. There was a company called Sapper, a company called Hook. These companies became part of Hydro. They were also independent customers of RIA prior to the merger and acquisition by Hydro. So Hydro has become, by growth, our single largest customer. Notably, some other large customers include Novelis, which is a downstream entity belonging to Hindalco, and Hindalco itself. We have supplied a furnace charging machine to Hirakud plant, which next month will be installed and commissioned in the DC4 cast house. That's a swiveling charging machine capable of charging 12.5 metric tons into a furnace in less than 90 seconds. Let's look specifically at the technology and how that relates to improved efficiency and safety. First of all, there is no operator cabin on our charging machines since the year 2014. So for 11 years now, we've been supplying these charging machines completely automatic without any operator cabin on the machine. That way we remove the operator completely from the dangerous and risky charging cycle, where there's always a risk of a potential splash, exposure to heat, or worse still, an explosion. Our charging machines are bespoke and designed to fit the size of the furnace or furnaces that they're serving. So we fill the width of the door, we fill the height of the door. We look to extend deep into the furnace, deeper than alternative technology that's on the market. We tend to go 2/3 into the furnace, and then we have a specific push-in cycle where we distribute the load evenly from the back of the furnace all the way to the front of the furnace, ensuring that we have shallower scrap piles and improved melt rates. And we've seen in applications sometimes up to 25% improvements in the melt rates, faster melting cycles due to that shallower scrap pile with a larger surface area. By using these machines, we see significantly less movement in front of the furnace from other vehicles, less maintenance required from those other vehicles. The machines that we supply come with integrated integrated load cells, so the operators know how much per push is being put into the furnace, how much per cycle solids is being put into the furnace. Because the machines are automatic, they need to know where they are in the cast house in relation to the furnace or furnaces. So we have laser position measurement on the machines that determine where they are in relation to the furnace, so that we can ensure when we enter into the furnace, we're not touching the sidewalls, we're not touching the refractory. These are completely non-contact. We have safety laser scanners on the machine, so as we move up and down the cast house floor, if we approach an object or another vehicle or a person, the machine will slow down and ultimately stop if that object doesn't move from the path of the machine. So complete safety. This video here and the graphic are synchronized together to show you what a typical cycle looks like. The machine moves in front of the furnace, it sends a signal to open the door, it extends into the furnace to that 2/3 length of the furnace. Pusher plate moves up to a predetermined position stops, and then our container retracts against that pusher plate. And as the container retracts against the pusher plate, the scrap's being pushed off into the furnace from the back all the way to the front. And we can do that always less than 90 seconds. Rather than showing you a graphic in operation, the important thing to note here is this is not a video made by Rio. This is a video made by one of our customers, Hydro. So the words that Hydro use are Hydro's words, not Rio's. So here they're talking about a circular economy. They talk about efficiency. They talk about cost savings, sustainability through use of that machine. Again, you notice that there is no operator cabin on the machine. It's fully automatic. We provide a remote operator station, and in this case the operator has a single push button that activates the machine. The machine moves to the furnace, sends the signal to the furnace controller to open the door. When it receives a signal back that the door is open, the machine extends into the door, into the furnace, delivers the load, retracts back out and returns back to the loading position, all fully automatic without further interaction from that single push button. Just to show another application in operation, real-time video. If you want to time it, the cycle from when the charge container starts to extend now to when the container is back to that home position and the machine starts to move away from the furnace is 45 seconds. And in that time, this machine is capable of delivering 15 metric tons into the furnace. Now, if we can do that and we deliver the load evenly from the back to the front, we get that shallow scrap pile. We don't have a heap in front of the burners that are blocking the heat to the rest of the furnace. We can use cameras inside the furnace, which I'll come to in slides to come, to actually determine when is the optimum time to make that charge. If we can do that, we can minimize the number of door opening times. We can minimize the total amount of time that the door is open per cycle. So we can keep heat in the furnace. We can reduce your cycle times. We can save energy. Here we estimate 5% energy savings by minimizing the door opening. A reduction in dross generation of potentially 0.3%. So if you're generating 2% dross typically, we could expect to see that fall perhaps to 1.7% just by minimizing that door opening and minimizing the amount of oxygen that can get into the furnace. Why do we want to take the operator out of the process? Two very self-explanatory photographs here. I don't actually know where these locations were. These images are available on the internet. You can see in the first one on the left, a catastrophic explosion. Looking at the debris on the floor, I would say that's had a significant effect on the cast house. And we've all heard of examples where explosions have taken place through the combination of moisture and molten aluminium, and those explosions have completely destroyed the cast house, and sadly lives have been lost. The photograph on the right is a forklift truck which has been charging a tilt rotary furnace, and there's been a back explosion there. You can see the aluminium all over the floor. That aluminium will have sprayed all over that forklift truck, which is now on fire. I only hope and pray that the operator or the driver of that forklift truck was able to get out of that location in time and without too much serious harm coming to them. In both cases, we could provide a charging machine without an operator, where if such an event had occurred, the charging machine would bear the brunt of that force and no operators would be harmed. I'll now talk about cameras, and then a little bit later we'll come back to skimming, but cameras here actually tie in and relate nicely to furnace charging and how we can take that automatic cycle from being automatic to autonomous. First thing to note is that Fearscope, since we made that relationship quite formal the relocation of the business and for Ria to take over the sales of the Fearscope technology, we've sold 107 of those cameras worldwide since 2022. They are air-cooled, and here are a list of our customers who are using that Fearscope technology. On the top line, you see a bunch of furnace builders: Jasper out of Germany, GHI in Spain, Incitec in Spain, Mechatherm in United Kingdom, and GNA based out of Canada, part of the Gauchi group, have all bought our camera technology and integrated it into their new furnaces that they're supplying to the customers. This is now becoming more of a, rather than an option, a standard component within new furnace technology. Other big customers for us: Novelis. As per a Ria customer, Novelis is actually our biggest Fearscope customer. Last year alone, Novelis took 23 cameras from Fearscope for applications in Brazil, United States, United Kingdom, Germany, and Italy, amongst others. You see also that Hindalco is a customer. We will deliver, install, and start up our first camera application at Hindalco at Muda in June of this year. Other significant customers include the likes of Hydro, where we secured one frame contract to equip every hydro cast house in Europe that didn't already have a camera on their furnace. So at that time, 8 cast houses invested in Fearscope technology in different countries throughout Europe. This video was captured from our very first installation. The installation occurred in 2014. This video was acquired in 2015. We had a video storage facility, so we didn't know what happened was going to happen, but after the occurrence, we were able to look back to see why. You can see some bubbling just to the front right of that sow in the furnace, and that's moisture escaping from contraction within that sow. And at a certain point, that moisture path becomes blocked. The theory is that there was a rapid rise in volume there and expansion, and that caused the explosion. Now, we were quite lucky, the customer was quite lucky, that that was a mild explosion. It was a loud bang, but the furnace wasn't damaged. Nobody got hurt in that particular incident. But it got us thinking, if a camera inside a furnace can see events, can you use that image to make decisions and take actions and maybe prevent such events? Now, what was clear in this particular case is the image which was displayed on a monitor in the pulpit in the cast house had not been observed for certainly more than 10 minutes when that bubbling was occurring. Otherwise, the operators may have tried to take actions to prevent that occurring. What could they have done? They could have certainly evacuated the area. At that time, nobody knew how significant the explosion was going to be. They certainly could have shut off the energy supply to the furnace so that there was no further heat being put in there. They could have called the emergency services just in case. So there were a number of things that could have taken place that may have prevented that incident from happening, or certainly reduced the risk of it being any more significant than it was. Fast forward to today, this is what we use that camera technology for. So the green polygon that you see is the intelligence system identifying where the solids are inside the furnace. So it's ignoring the door and the wall and the floor. It's ignoring the burner flames. It's just tracking the polygon, the shape of that scrap pile. Now we have a traffic light system. We're at the end of the cycle here where we're ready to receive the next charge. That's what the green light means. We're ready, we can go, we can proceed. So the door opens, here comes our charging machine, and in real time we just show that charging machine coming in and delivering the next load. So the first thing, as the intelligence is still rolling, it identifies the solids that are in the scrap container, links that to the solids that are in the furnace, and we now have a red polygon which says the furnace is not ready. So now we have the start of the traffic light cycle. So at the moment we're delivering the load into the furnace, and as I mentioned earlier, the charging machine is coming deep into the furnace and it pushes that scrap to the back of the furnace, to the front of the furnace. So we really make use of that space. Now we've sped up the speed here just so I don't have to talk or wait 10 minutes for this material to melt down. And as it melts down, you'll see we'll transition from red to orange, which means we're nearly ready, and then ultimately to green when that last piece of scrap billet drops down and is low enough to receive the charge car into the furnace to deliver the next load. So the cameras here now track the melting of the solids. Here we go in green, and they send a signal to the charge car, come and deliver the next load. So here we can take out the operator completely from the process and allow the cameras to determine when is the optimum time to load the furnace. Now that analysis has all been taken with the door closed, keeping the energy. I'll show another video that shows that as an example with some larger blocks here inside the furnace. Same thing, red, we're not ready, orange, nearly ready, green, we're ready. Now that could be the last stage of the cycle, flat bath. Now the furnace is ready for dedrossing, maybe sample taking, alloy additions adding, transfer to the next process or cast. Having taken the operator out of the process, here we see an example of a charging machine delivering a load, no operator cabin on the charging machine. There's a remote operator desk, but you can see nobody is driving it. This is fully autonomous. We have the cameras inside the furnace, which have called for the charging machine. The operator in the pulpit can observe everything, line of sight to the furnaces. We have cameras on board the machines where you can see what's in the charge container, how the charge machine is interacting with the furnace, etc. And in the background, just behind the charge machine, we can also see a skimming machine. We'll come on to those shortly. But at the right-hand side of the desk, you have also the controls for the skimming machine. You may need manual control on occasions, maintenance purposes, or if you want to move the machine out of the way for other maintenance to occur, then you can do that using the joysticks and manual control. But otherwise, these machines are either, as a minimum, fully automatic or fully autonomous. You don't need an operator to be on the machine. Again, just to show the range of applications that we have with these in-furnace camera technology. It's not just single chamber reverb melting furnaces as top left. Top right, we have a multi-chamber where we can see scrap that's put on a ramp through one door, and then the successive charges push that scrap into the bath area, which is on the right-hand side of that image. And the door that's behind that on the other side of the furnace is for removing the dross out from the side. Bottom left, we have decoating technology. There is no burner flame in this application, so it's a dark application. We're working in near infrared, low light conditions. Here we're looking for sparks from volatile lacquer as that's burnt off from the scraps. And bottom right is inside a tilt rotary furnace where we mount the camera inside the door, very close to the solids, very smoky, very fumy application. But again, we have a view into the furnace, a view that is not possible in these applications without otherwise having to open the door and allow the heat and the energy out of the furnace. Let's talk about skimming machines then. Skimming machines are not just purely for skimming. They are designed for skimming the dross off the furnace, but also mixing and stirring the furnace and cleaning the furnace, the walls, the floor, before alloy changes, for example, both for melting and holding furnaces. Most of our skimming machines are supplied with an operator cabin on the machine, but that's not necessary today, and some of the more recent machines have been supplied without operator cabins. So again, if you wish to, you can keep the operator completely away from the machine, not have an operator cabin on the machine. The machine can be fully autonomous. It can be operated manually as per the charge car from a remote location using cameras on board the machine, or it can follow an automatic robotic skimming pattern, or it can be fully autonomous, again using the same camera technology that we use inside the furnace and using the smart capabilities of those cameras to make decisions about where the dross is. One thing to note about these skimming machines is that they are fully programmable. The PLC knows exactly where the skim boom is and therefore where the blade is in relation to the back wall, the side walls, the floor and the ramp. So we're not going to accidentally damage or contact that refractory, cause damage that requires further downtime and reparation work. We have applications where we put charging and skimming machines into new furnaces that haven't needed a major reline for 8 years because the refractory has been protected by the machines. We air cool the booms. The booms are not submerged. We design the pivot point in such a way that the boom does not get submerged in the surface and therefore does not get eroded. It's quite typical for those booms to last more than 10 years and beyond. And we have a unique process which is patented by RIA, which we call IFDP, or in-furnace dross processing, and I'll show that shortly. Just to show hands-free operation, here we put a GoPro inside the operator cabin. There is no operator in that cabin, just the GoPro, and you can see that the machine is doing its own thing, hands-free operation. So we can follow those robotic patterns, or if we put the intelligent cameras onto the machine itself, that machine can make the decisions about where the boom goes to remove the dross from the furnace, or what pattern it follows for stirring and mixing, etc. I'll start playing this video. The whole video here for one complete skim cycle was 10 minutes. I don't have 10 minutes to play the entire video, but just to show you a lane here of what we call IFDP. So we add a cold plate to the skim machine, and if you look at the image on the right, the still image, you see the skim blade and the cold plate, which are cast steel profiles. They are cast in such a way that they mesh together when they come together to press and squeeze the dross. So we bring the dross off the surface, bring it up onto the sill, press it for a predetermined time, and then there's a number of actions that we can take. Either we can lift that and allow the dross to drain whilst we're holding it back into the furnace, or we can take it out into the dross pan. In this application, as I mentioned, 10 minutes, start to finish, skim the dross, press the dross, remove the dross from the furnace, close the furnace door, transfer the liquid, go on to the next stage of the process. That IFDP has been shown on 6000 series billet applications to reduce the weight and volume of the dross that's removed from the furnace by in the region of up to 35%. And that reduction in weight and volume relates to liquid which actually stays in the furnace and is available at no extra cost or immediately transferred to the casting lines as finished product with no additional energy or handling. Here we see a photograph on the left which is non-IFDP, so that's just straightforward skimming from the furnace, and on the right what the dross looks like after an IFDP application where there's clearly less volume. This leads to less additional handling, less transportation, less recycling costs, or less landfilling. Skimming machines are not just solely used, as I mentioned, for skimming and stirring and mixing. Not what they were intended for, but they often get used for load spreading, opening up the scrap pile, exposing the center of unmelted solids to the heat of the burners, lowering the scrap pile, which allows you to bring the charge car in sooner to move to the next stage of the cycle. Or if you have an electromagnetic stirrer or another circulation device, you can get those solids down below the surface and let the movement of the warm liquid aluminium passing over those solids break down those surface barriers and increase the melt rates. So load spreading is another benefit from using these rail-mounted skimming machines. Now the cameras that were on that skimming machine that captured that video that you saw are not actually there for that purpose. They're there to aid us for what we call autonomous skimming. So the cameras can identify exactly where the dross is located and then make an intelligent decision about how to skim that furnace. For example, if you have a circulation device that actually moves the dross from one side of the furnace to another, when you open the door, our cameras will identify that half of the furnace surface, bath surface, is clean and therefore not waste time skimming that area. It would just go to the area where the dross is. Secondly, if you have just a robotic skimming action where you skim lane by lane, a system that doesn't have a smart camera on board doesn't know how well it's done. So it completes the robotic pattern. It assumes everything is good and finished, but it may be that as you're skimming the next lane, dross may move into the clean area which has already been skimmed. A human being would notice that. He would go back and capture that dross and remove it from the furnace, but a robotic skimmer doesn't know that. Putting the smart cameras on, we can see when that occurs and we can make a decision about where to go back and when and how. Just to show that in action, you can see here we divide the bath surface up into a grid. We make decisions about the cleanliness on the grid, and then we determine where to put the skim blade to remove that dross from the furnace and how well the system is performing as that happens. And you'll see here that some dross has been left behind. We go back and we capture that and remove that. We redo the analysis in real time and determine whether the job is finished or not. Okay, just a reminder as we're getting towards the end, what those products are actually providing for us. And the two things that I set out to try to bring across here were safety and efficiency. So increased plant safety by removing the operator from the process in the first place. It may be that you've operated plant for several years without accidents to operators who are driving mobile vehicles. But there's no guarantee that that won't occur in the future, just based on the fact it hasn't occurred so far. So improved plant safety by removing the operator, increased plant productivity by reducing the number of times the door is open and the amount of time that the door is open for. I did mention earlier that we will guarantee that all of our machines, whatever capacity they are, will deliver the load in less than 90 seconds. And quite often today, that is sub 60 seconds, depending on the stroke and how far we need to go into the furnace and how much the container holds. Incidentally, the largest container that we've supplied to date is 30 metric tons. And we will deliver 30 tons into a furnace in a single push in less than 90 seconds. If we can do that, minimize the door opening, we can shorten the cycle times, we can keep the heat and energy in the furnace, a win for the environment and a win for productivity. By having that precise movement, by being fixed on rails, we know we can ensure that we're not going to be touching the refractory, we're not going to be damaging the refractory, and that your refractory life will therefore improve. We know that if you need to take the furnace down for a major reline, that furnace is going to be out of operation for at least a month. If you can prolong that refractory life, you get increased productivity during the lifetime of that refractory. All of these operations can be not just manual, but typically automatic for the charging machines. Automatic is an option for the skimming machines, and autonomous is an option for both types of machines. and we can reduce the amount of dross that is generated, again, by minimizing the door opening times and reducing the amount of fresh oxygen that can come into the furnace with the door open whilst you're charging, coming backwards and forwards with forklift trucks or front loaders. So if we can reduce the amount of dross that's being generated and then skim that with a skimming machine with IFTP, we can potentially increase the amount of metal recovery that you're receiving. So the amount of liquid that you cast per cycle would directly increase as a result of IFTP. So improved yield. Brings me to a close. I again would like to thank all of you for your attendance and thank IBAAS for making today possible. I've been a little bit shorter than anticipated, but that means I'm available for longer for questions and answers. So I will remain as long as it takes, and I'm happy to take your questions.
Thanks, Mark Bumford. Very beautiful presentation. It's about 40 minutes presentation. Now it's open for discussion. And please, you are free to ask question to Mark. He is available online. Kurt, if you have any question, please start.
I see someone raise their hand during the presentation.
Yeah, one Satyanarayan Das is here. So, Mr. Das, you can start your question. Hello.
Hello.
Yes.
You have said that there is in-furnace camera which doesn't require operator, and is it a artificial intelligence enabled camera?
Yes.
And how it ensures no explosion? Explosion is eliminated, which is a great hazard in cast house.
Yeah, you're absolutely correct. Quite frankly, the cameras cannot guarantee that you won't have an explosion. The example that I showed had a recording system. So even with the camera, which was just visual only, that very first installation without any intelligence, did not notice on the monitor that the event was happening and likely to occur, so didn't take any action. It was only because we had a recording system that after the explosion, we were able to look back to why that happened. So let's come to today's technology, where we have the ability through a neural network to train the cameras to react to certain events. One of the problems is you need to show a camera an event against which it can learn. And I don't suggest that you try to create an explosion to try to teach a camera what an explosion looks like. So our cameras are there that visually you can make such decisions. But what they are capable of doing is determining that the scrap pile is low enough for the next charging machine, when to call for the next charge push of scrap into the furnace, or when the furnace has flat bath. Those are things that occur every cycle, so we can actually teach and train the camera what to look for. So we won't guarantee, I don't think anyone can, that we can prevent an explosion. But we can certainly give you the tools that allow you to perhaps predict that there may be an unsafe condition and take actions.
Yes, you are right. It can only predict, but cannot be eliminate. Is it that? Okay.
That's absolutely correct. And sadly, so I've worked in the aluminium industry for quite some years, and I've been involved in cast house specifically aluminium cast house applications, since 2010. So some 15 years now. And I travel the world, meet many different varied applications. And I've come to the conclusion that sadly, these explosions occur potentially every day somewhere in the world. Mostly, they're just a bang, a loud bang, maybe a small splash of aluminium. Nobody gets hurt, thankfully. But also occasionally, and we've all seen the press, this is much more serious. And I have one client in Norway where a much more serious explosion occurred. Sadly, the entire cast house was completely destroyed because of liquid aluminium going up into the roof and the roof catching fire and the roof collapsing. And 2 people lost their lives. And we know of these incidents when the big ones occur and get reported. We don't know of these incidents when it's just a bang, nobody got hurt, and people say, well, we were lucky there. And the process goes on.
Okay, clear. Thank you.
Yes. Any more questions? There is a team from Sri Lanka. Is anybody interested to ask any question? Kurt, do you have any question?
No.
Please check anybody else is interested to know anything about this process and about this furnace. You are welcome. You can ask any layman questions also, please. Okay, I think there is not many.
We have a hand up there from Adhiraj Seth.
Adhiraj Seth. Yeah, Adhiraj, please go ahead. Adhiraj, please go ahead. Unmute your sound, please, Adhiraj. Can you hear me?
Maybe he put his hand up by mistake.
Okay. No, he's
No.
there, Adhiraj. Yeah, please unmute.
Maybe the microphone's not working. Do you want to put the question in the chat? I'll see if I can answer it.
Hello.
Oh, good, Adhiraj. Please try to unmute.
Hello.
Oh, Kiran is also here asking question.
Hello.
Yeah, who is Kiran?
Computer vision. All right, I can see the question now from Adhiraj. He asks about the AI technology in the computer vision. So let me explain for people who've not come across RIA or Fearscope in the past. We can supply these cameras as part of a bigger package in conjunction with our charging machine or with our skimming machine, but we also just supply the cameras. Okay, so we can go into an existing cast house and we can retrofit those onto existing furnaces. And we're doing just that at the moment in a project with Hindalco in Moda, near Nagpur. So the cameras start as a basic visual only application. So by having a camera inside your furnace, you can observe on a monitor what's happening inside the furnace, but here's the beautiful thing, from a safe location and with the door closed. So you're not putting any operators at risk, and you're not opening the door, stopping the burners, letting heat out of the door, letting the furnace roof cool down, and that energy needs needs to be replaced afterwards. So that's the first step. The cameras allow you to see inside the furnace with the door closed. Don't slow the process down, keep everyone safe. Secondly, those cameras, we can add intelligence to them retrospectively or from the outset. And that intelligence is based on a offline neural network that we have back in Germany. We can run images from your process through our neural network and teach it to learn certain features. For example, you might be interested in burner flame. If you can show us the images of what your burner flame looks like when it's optimum and tuned, the length of the burner flame, the shape of the burner flame, maybe the color, we can run that data past our neural network and teach the system what a good burner flame looks like. And then we can set some parameters that if that changes, if the burner flame is not as long, or it's fatter rather than narrow, or the color changes, then we can actually give an output. So that's how the AI part of the technology comes into the cameras. It's optional. As a minimum, just putting a camera visual only into your furnace is a major step. It's beyond what you have today. Immediately you safeguard the operators and you improve your efficiency. Then adding the AI capability to that takes it to the next level. So we have many customers who start out with a visual only, maybe just one camera in a furnace. Perhaps later on they add a second camera. I had to limit what I talked about in this presentation, but the reason why you might want to add more than one camera is, imagine putting a camera on one side of the furnace. You can see the other side, but you can't see the side where the camera is. You can't see what's below the camera or immediately around the camera. So putting a camera on the other side of the furnace allows us to see perhaps all of the furnace contents. So we have customers who start with one camera, visual only, add a second camera, and then later add the automation capabilities to that. Something I didn't touch on was refractory damage. If we've got a camera sitting there 24/7 looking at the wall opposite, we can actually track long-term trends on the refractory. So for example, if there is a crack in the refractory, we can determine, is that crack propagating? Is it getting longer? Is it getting wider? Is it getting more serious, or does it actually grow to a certain point and stop? And using that data, you can determine, do I need to stop the furnace now and take some repair work to prevent a breakout? Or can I actually go longer rather than stopping as planned in 1 or 2 months' time? Looking at this, maybe I can go another 6 months. So you can use the data to suit whatever you want. Okay, and the original question was, is it computer vision? Yes, it's a neural network that we have, that we then upload that intelligence back into the system to make decisions.
Okay, Mark, may I ask now, Kiran? Okay, he has already answered. Manoranjan, have you? Yeah, Manoranjan. There is a query on the writing. One, Manoranjan, have you installed a camera at Hindalco, Mauda?
We are about to. The furnace, I was actually in India in February. The furnace was down for reline. The reline took into account of the locations for new cameras, and Hindalco have purchased one camera which will be installed on that furnace. We will deliver it in June. Hopefully later on in June we're present on site for the startup of that camera. Certainly no later than July, but hopefully in June that will take place. The furnace is prepared for 2 cameras, as I mentioned a little earlier. Why? Because they're putting the camera on the back wall, and that'll allow us to see the front, see the ramp, see one of the burners, so we'll be able to see what the flame looks like. But that location doesn't show us where the transfer position is, and it doesn't show us where there's movement between the 2 chambers of the furnace, where there are channels, where the circulation device creates that that movement between the two chambers of the furnace. So the second location, which they planned for, whilst the furnace was down, it was no extra cost to prepare for two, will allow for adding a second camera in the future from another budget period, and that will look at the areas where the first camera can't see. So from June, at some stage in June, hopefully that camera will be operational.
Thanks, Mark. There is a question from Kiran and Satyanarayan Das again. So Kiran, please go ahead.
I don't have a question, please. Somehow I don't have a question.
Okay.
So put your hand down.
So Kiran, please go ahead.
Mark, typically, what is the life of the camera? And
Yes, so the very first cameras we installed were in the year 2014. Two cameras were put on that furnace, and they were just purely visual only. And they both operated continuously. They were not on a retraction like we offer today. So they were permanently inside that furnace 24/7. And they operated continuously, both of them, until the year 2022. And in 2022, they relined the furnace walls for the first time since 2014, when we installed the cameras. They did that work without us present. We weren't involved. They took our cameras out. They put a new refractory lining in. They put the cameras back in. And one of the cameras they put in too far. So normally they sit inside the refractory thickness of the wall, and when they reinstalled them, the camera was installed too far, so it actually protruded through the refractory. We have a charging machine on that furnace, so after the startup, after the furnace had been dried out, first charge, no one had noticed. Our charging machine contacted the camera and took the camera out of action. If that had not happened, it would still be in operation today. And I'm glad to say that my charging machine won the battle rather than the smaller camera. But if that had not happened, both cameras would still be in operation. And that's now from 2014, that's 11 years. One camera is original and still in operation after 11 years. So I can't predict anything longer than that, but I can tell you that that's the longest continuous running application that we have.
so, Mark, in case of cameras which are helping human beings seeing what they cannot see with their naked eyes, and yeah, in the operations which are into confined space, do you imagine that these cameras can be used somewhere else in the aluminum upstream?
Well, potentially, yes, Kieran. I think you missed part of the presentation earlier. I showed a couple of different applications, not just in melting furnaces, but we have them in delacquering furnaces already, which are removing volatiles, lacquer, etc., from coated material before feeding into a sidewell. We've been asked by our biggest customer to look at some applications outside of the furnace. We had an application, well, we have more than one, where we're now looking at the spout on the outside of the furnace, and they were interested in the event of a bleed out that we could put intelligence into the system to alert them that they had a leak. And we actually installed that system, and it took several months before they had a leak, before we could take that data and then put that intelligence into the system. But I'm pleased to say that we've been able to do that now. We've run what that leak looked like through the neural network. We've re-uploaded that back into the system, and that system is now triggering them when that occurs. So when they get a small bleed out from the stopper, from the pouring spout, the system will alert them to that.
Interesting. Interesting. Yes, Jagdish, please.
Mark, how is the scrap loaded into the charger?
Okay, so that varies from application to application. I would say the majority of our customers are extrusion customers, or certainly they're casting billet. But we also have more recently, in recent years, more customers who are buying these machines for rolling applications. So different for both. In some cases, there are commonalities. For example, most people are putting some kind of prime into their furnaces. So that would be prime in the form of ingots, or they may have sow, they may have T-bar. Those things can be handled with forklift trucks. If we're talking about extrusion, quite often people are putting extrusion bundles into the furnace. These can be 6.5, 7, 7.5 meters long even. And in those cases, you need a furnace that matches those dimensions, and you need a charging machine that matches those dimensions. So those are put in usually with a wheel loader or a front end loader, as we call them in Europe. And they may have a special tool, which is a grab tool, which picks up those bundles. They can put them over the sidewalls, because the machines, you might have noticed from the photographs and the videos, are very robust, very solid, very rigid. It's not a problem to put those over the sidewalls and just let them drop onto the floor of the container. Our charging machines, the containers, the floors are potentially 380 mm thick. So they're very, very rigid, very solid. They've got to be, because they extend into the furnace a long way, and we don't want them deflecting and flexing. We want them to be rigid and solid. So that allows us to drop these weights from a height. So typically, forklift trucks, front end loaders or wheel loaders are used for putting the material into the containers.
And the second question is, the cameras are air cooled or nitrogen cooled or air cooled?
They're absolutely air cooled. So we started with that technology in 2014, and I talked about those cameras. One of them is still in operation after 11 years. The other one got damaged. Those very first cameras were water cooled. When we came across the technology, it was being used in the glass industry. Our partner Fearscope came from that background, working in glass. We brought them to aluminium because of our use of the cameras for our equipment. And now we focus solely on aluminium. It's our marketplace, and it's us, RIA, who are leading the sales, and we only work in the aluminium industry today. So that technology, which was originally water cooled, one of the things we wanted to do first was take away the risk of water and water leakage. We all know the consequences of that with liquid aluminium. So we provided an air blower to actually provide the main cooling for the camera probe. And we take a compressed air feed from the client, which we also use for what we call rinsing air, which we use to trickle a continuous flow just to prevent the ingress of dirt and contaminants into the camera. So today, 100% air cooled. We, RIA, also developed the retraction mechanism for that. So I already mentioned that those first installations were permanently inside the furnace. That's great as long as you keep the cooling on 24/7. If you, for some reason, lose the cooling, if you lost power, for example, you've got no cooling left, and you're going to eventually cook that camera and burn it. So we added the retraction mechanism for safety and convenience. From a safety point of view, it's a pneumatic retraction. If we lose the power, the valve is normally open, so the retraction automatically retracts from the furnace. We've got a thermocouple inside the camera. If we see a critical temperature, the camera will retract from the furnace. And today, we link that to the furnace controller as well. And when the door opens from the furnace, we can retract the camera. You might ask, why do we want to do that? Because when you open the door, there's usually something coming into the furnace. You don't need to open the door to look anymore to check on the status of the melt cycle, because that's what the camera is for. But when you do open the door after you've installed a camera, you're going to charge, or you're going to skim, or you're going to stir, or you're going to alloy, take a sample. So usually when you do that, something is coming into the furnace, and then there's a risk of a splash. We've seen splashes from stirring operations that create a bow wave, and the bow wave eventually splashes up to where the camera is. Putting solids into the furnace at any time during a melt cycle, there could be a liquid pool and there could be a splash from that. There could be a small pop or explosion like the video that we showed earlier, but it may be even smaller than that, but still liquid moves around in the furnace. So to minimize the risk of splash, as a precaution, we retract the camera out of the furnace during door opening times. We also learned that it's good practice to delay putting the camera back into the furnace after the door closes. And this came from experience, and you might ask why, and I don't mind sharing. When you charge material into the furnace, particularly if you use a high capacity charge machine like ours, and you put a large mound of scrap into the furnace, you close the door, you turn the burners on full power. You want to get that solid melting down as quickly as possible. When you do that, there's a lot of turbulence inside the furnace, and that movement and that heat causes the melting of the outer surfaces of the scrap. And we've seen incidences where there are small droplets of aluminium flicking around the furnace for a period of minutes until that scrap pile starts to melt down a little bit lower. And we found that if we delay putting the cameras back into the furnace after the door's closed after a charge for about 5 or 6 minutes, we minimize the risk of any splash coming to the camera. So you might miss 5 or 6 minutes, but you still have plenty of other time in the cycle where you can see exactly what's going on. And it's not those first 5 or 6 minutes that are interesting to you. It's the latter part of the cycle.
Thank you.
Welcome.
Very good, Mark. Very nicely you have explained, and a very useful session. And we will put this presentation on IBAAS website, and also it will be available on YouTube. And anybody interested to have more questions, they can correspond with our office, and we will redirect questions to Mark Bumford. So you are all welcome, and you can write your questions to us, and it will be forwarded to Mark. Thank you very much, Mark. We are almost to 1 hour now, 5 o'clock in India, 5.02. So it's good session. And thank you very much, Mark, for your answering all the queries. So
you're welcome. Thank you.
I don't think there is more queries, but if there are queries coming afterwards, our office will forward you. Thanks, Mark.
Thank you, Anand Kumar. Thank you.
Thanks.
Thank you.
See you then.
Bye-bye.
Bye. Bye.